All right, well, hello, 8th graders. This video is meant to just kind of debrief the practice activity 1.2, number one, I guess. Sometimes in this self-paced structure, as opposed to me writing out feedback, it'll be your job to actually make corrections based on basically an answer key that I give you through one of these videos. So here's your opportunity to experience that right now. So your first job in this practice activity was to create pie charts to document the different energy accounts that are present at various positions or various snapshots within these scenarios. So first one here, this is basically from the notes that you should have taken. We have this ball being dropped from rest. So the objects in our system, remember we always want to label those objects in our system. So in this case it's going to be the ball and the earth. And because those objects in our system, our initial snapshot there, we have all gravitational potential energy. So in this case, we can label it UG. We can use PEG or UG for gravitational potential energy. I just get lazy sometimes and I write UG. All right, so now our next snapshot here. Looks like we're about halfway, maybe a third of the way down. Regardless, what we should be seeing there is that some of that gravitational potential energy is being transferred into the kinetic account. Okay, so we're seeing that the total energy that we have in this ball earth system is the same, right? Because that's what the size of the pie represents. But we're seeing some of that energy being transferred to the kinetic energy account. All right, and then finally, right before that ball hits the ground, all of that gravitational potential we started out with gets transferred to the kinetic account. All right, next one. Truck driving at a constant speed down a level roadway. So the objects in our system here, we have the truck and we have the earth. Now, if you look at this system, this truck is at ground level, so there is no gravitational potential energy. There's no elastic objects here. And if you take a look, all of these motion arrows that you have here, they're the same length. So that means that this thing is moving at a constant speed or constant velocity, whatever you want to say. So every single pie chart for this one should look like that. Okay, the only energy account that's being filled at all three of those snapshots is your kinetic account. All right, last one here. We have an object pressed up against a spring. So this spring is compressed and then it is released. And then this blob or this object ultimately for that split second is at rest at the top of its motion there before it starts falling back to the ground. So the objects in our system, we have the spring, we have the blob, and we have earth. All right, now we're going to say that this right here is zero height. Okay, where this blob starts, we're going to say that that is zero height. So that makes these pie charts a lot easier. And we're going to come to find out that we can really set zero height anywhere we want to make our lives easier. Okay, so what I can do here is I can say that that's zero. So that means then that in this system, the only energy account that's being filled is elastic potential energy. Okay, whenever we have an elastic object and it's stretched or compressed, we know that elastic potential energy is present. Now, second snapshot here. We no longer have elastic potential because this spring is no longer compressed, but this blob is now at some height and it's moving. So we should see a pie chart that shows that elastic potential energy has now been transferred into your gravitational potential and your kinetic account. Now, last but not least, our final snapshot. This blob is no longer moving. It's for a very small amount of time at rest before it starts falling back to the ground. So, our final snapshot. our final pie chart should just be all gravitational potential energy. All right, now these LOL diagrams, and these are what we're going to be using most often in this unit and in this class, really, because they're a very nice way for us to document initial and final amounts of energy based on the snapshots that we take. So, first things first, remember the O portion of our LOL diagram is where we document which objects we have in our system. So if you take a look here, what do we have? We have the track, we have the spring, we have the cart. Okay, so what I'm going to write for our objects is I'm going to write cart, spring, and we always include the earth. So there's the objects in our system. Now, our initial snapshot right here. Our object is on the ground. There is no height. This object is not moving. However, it is compressed against this spring. You can see that this spring is compressed. So the only energy account being filled for that initial snapshot is elastic potential energy. Now our final, we see that our cart is now at some height above the ground and it's moving. So what does that mean? That means that that elastic potential energy has gotten transferred to the kinetic and the gravitational potential account. So what that should look like, it should look something like this. Now notice that if I were to add up this and this, it's going to equal this. Okay, I have 1 bar plus 1, 2, 3 bars. 1 plus 3 is 4. Initially I had 1, 2, 3, 4. That's what the conservation of energy tells us. The amount of energy that we have initially has to equal the amount we have finally. Okay? Alright, now number 5. Same exact scenario, but take a look. Our final snapshot is at a different location. That is going to have some big implications for us. So again, we have the cart, we have the spring, and we have the earth. All right, now initially, again, that cart is just pressed up against that spring, so we have all elastic potential energy. Now, this cart is not at as great of a height as it was in number 4. So that means that we have less gravitational potential, but again, because we have to have the same amount initially and finally, we actually have more kinetic energy than we did in number 4. So take note of the difference between 4 and 5 here, just based on that final snapshot that we took. All right, now, last but not least, we have a moving block. Hits a spring, and then the spring brings that block to rest, and then the spring becomes fully compressed. So, defining our system, what objects do we have in our system? We have the block, we have the spring, and we have the earth, always the earth. Now, initially, our initial snapshot, the block is moving. It is at 0 height, and that spring is not yet compressed. That only happens finally. So initially, the only account that's being filled is our kinetic energy account. Now, finally, we're told that this object, the block, comes to rest. It's still at 0 height, but now this spring is fully compressed. So what happened? All of the kinetic energy from the block was transferred to the spring. So now our elastic potential energy account is being filled. Okay, notice how the energy changed accounts within this block, spring, earth system. That's really key, and you're kind of seeing this in all of these. Objects within systems can transfer energy to different objects, but that does not change the amount of energy you have in that system. Okay? Now the last thing, and you haven't really seen this yet, but I included it for a reason. We can create little mathematical equations for the conservation of energy. So what we say with these conservation of energy equations is that the energy that you have initially has to equal the energy that you have finally. So let's take a look at number 6. What does that look like in number 6? Initially, all we had was kinetic energy. So to start out our conservation of energy equation, we would just write kinetic energy initial. Okay, so this I just denotes that it's initial, equals, well, what do I have finally? Elastic potential energy final. That is your conservation of energy equation for that scenario in number 6. So I would challenge you to try writing conservation of energy equations for 4 and 5. If you have any questions, you're confused by anything in this practice activity, please let me know.